Look at all of you people. This is so great. Thank you all for coming. It's really an absolute pleasure to be here. We have a lot in common. Despite potentially different pathways through life, I hope to touch on some of the things that we have in common and help with some of our potential heartache, specifically this week. So I want to start by saying, thanking the organizers. It wasn't clear to me when they reached out that I was the right speaker for this group. And I hope that by the end we can have a dialogue, and we're going to try to leave a lot of time for questions. I'll come down there and talk to you because I will learn as much from you as you will from me. But I start by saying I'm not a climate expert. I've been around people who are and picked up some of it, and I hope this doesn't gross anybody out, these pictures. This is my life, this is what I do, and these are the kind of problems that I deal with. But I've had to learn because, as you'll see, this affects everyone, including the health of the patients we treat and the health of the generations to come. And like, pediatric neurosurgery, we take care of children with life-threatening problems. We do surgery on them. We treat kids who don't need surgery but need management for things like severe trauma. And it can get pretty narrow. My research was in traumatic brain injury, especially in very young children, and particularly kids who were victims of child abuse. And so I ran a laboratory, which I still participate in, but luckily no longer run. But nature was always a call, and this particular case is what gave me the decision to revamp my career in a somewhat different direction. This was a kid, a great kid, who suffered from a disease that the cause is not known. Someday we'll have better treatments for this, but currently the best treatment is surgery. And it's a disease that we don't understand that destroys half of your brain. It's probably autoimmune in some way, but the only treatment is to remove or disconnect half of the brain. And the problem is when you do that, the kids take a hit from that destruction that you cause, but it stops the disease so that the disease does not progress and it's not fatal if you do that dramatic intervention. The problem was that the side of this child's brain that was involved was the side that controls his language and also his dominant hand. And so we knew that doing this would make him unable, potentially, to speak or to understand language, which is a terrible disability. And the parents, the disease slowly progresses, so the parents really struggled with the decision whether to do the surgery or not. And the child himself finally said, "Would you just do it?" He was like 8 years old. "Would you just do it? Like, I want it done." And that helped the parents to decide, and we did it. And it was quite an elaborate surgery because we were not 100% sure of the diagnosis. We had to have this team of people take some pathology. It was a big deal. It took all day, but it was done successfully, and he was cured of his seizures, and gradually he recovered his language, which is what you hope, to levels better than it was when we started. And the parents lived in New Hampshire, and they sent me this photo a month or so after his surgery. He was paralyzed on one side from the surgery and from the disease. But he was determined that he was going to climb to the top of this fire tower in New Hampshire. And you can see that the fire tower is perched on a big granite outcrop. And that's him at the bottom on the lower left there. And that's him at the top looking out. And the mother sent this photo with a note that said, "I wanted to send you this because it is, to me, to the mother, represents him looking out to the rest of his life to a life without seizures, because the seizures are cured." But it struck me as a kind of a guilt, a kind of responsibility. Here I am in this very rewarding, very satisfying career where people thank you for doing the things you do, and it's very immediate, very cause and effect. But I knew about climate change, I knew about environmental decline, I was very concerned about them. And the thought that struck me when I looked at this picture is, isn't it partly my job to do something to protect that world he's looking out on? Not just for him, but for all the other kids. And it sort of shifted something that said, you can't just hide, you have to take action. You have to do something not just for the few kids that you have the opportunity to treat, but for all kids now and in the future. So I'm going to make you feel bad, and then I hope I'll make you feel good. So a lot of times at the beginning of talks, I give an outline of here's what we're going to cover. I'm going to tell you instead your emotional reaction, which you may not have, but most people, when I give a talk like this, have this, which is you're going to feel like crap, and then at the end, I hope to give you some hope. And I think that's sort of how many of us feel right now anyway. And I want to start by saying that we're going to talk about the brain. We're going to talk about how it works, how it makes decisions. But let's start by saying it's really hard for the human brain, for reasons that make evolutionary sense, for us to think long term. It's a real challenge for us. It's much easier for us to think about, in my business, the child in front of me, the family right there, the kid's next birthday. Much easier to think about that than this child's future children, or even in 20 or 30 or 40 years. We tend to think short term, and there are reasons, evolutionary reasons for that. And so I want to talk about these three curves. I'm going to introduce this idea, and we're going to bring it back up at the end. But if we really think long term, you're thinking, many of you, about land conservation, land preservation, health, healthy ecosystems, and so forth. But I want to talk about the superimposition of these three curves that are going to determine the next 100 years. So let's think ahead. It's hard. It's hard for us to think beyond our own lifespan. We can theoretically, but emotionally it's difficult. So these three curves, I've lined them up so that they're in alignment, but the x-axis are, of course, very different scales. Let's start with temperature. This is an intergovernmental panel on climate change graph of temperature under various scenarios, depending on what we do. And you'll see that the middle is 2050, this is 2100. And these are degrees centigrade, and you can see there's a big thing here, big shift, whether we do certain things here or whether the people in the planet do other things. So those pathways are determined by our choices around the world. The second curve is lined up to be the same place in the middle, but it's a different scale. This is world population. And up until, relatively recently, human population was about 1 billion or under 1 billion, gradually, increasing. And then, during the industrial age and after, we've had this very, very rapid rise in population. Here's where we are today, about 8.5 billion. It's expected we'll get up to 10.5 billion, and that peak is anticipated for about 2060. Nobody is sure, but the predictions are, based on current fertility changes, that the population will plummet. And just like these curves give you different options, these curves give you different options too, depending on our behavioral choices, but all of them show a rapid decrease in population. The third is a harder one. This is conceptual, and it's not, this graph is a logarithmic graph. This happens to be something called Moore's Law. Some of you may have heard of this. This has to do with advances in semiconductor technology. What does that have to do with land? You guys are going to think I'm nuts. But this is a logarithmic scale, meaning that every bit here is up by a factor of 10. And this is also lined up to be at the present time. And this is representing the pace of change. So science and technology grow not linearly. They grow algorithmically, they grow exponentially because they build on each other. And this semiconductor graph of Moore's Law is an example of that principle. And I am going to posit that part of our problem in the world right now is this part of the curve, this pace of change curve. Because the human brain is very adaptable to change. If it weren't, we couldn't have survived and populated the whole world like we did, lived in different cultures, different mores, different kinds of societies. We have to be adaptable to change. But I believe that we are starting to outstrip our ability to cope with the pace of change because it's accelerated so much. This is not an original idea. Alvin and Heidi Toffler, who wrote Future Shock, a book that came out in the early 1970s, predicted this, but it has continued to accelerate as we would expect. And therefore, in reaction to this rapid pace of change, I believe this explains in part some of a tendency towards what I'll call in general conservatism. That is, whether it's religious fundamentalism, whether it's political conservatism, whether it's authoritarianism, this idea that the world is changing so fast in every way that I just want something stable. I just want somebody to tell me what to do, and if I do this, I'm a good person and I'll go to heaven, or you name it. And you add climate change into this mix where the entire planet that you live on, that we've always counted on as the stable thing, is changing. And this is really, really difficult for people. So our challenges in general are to get over the hump of the three curves. This one is a wild card because of AI. Like, some people predict the pace of change will slow as the population slows because it's dependent on humans to drive it. Other people are not so sure. So this is the one we know the least about. These two we know more about, except that we have to choose the right decisions here. And then we have to, as Katie said, we have to create a vision of the future that draws people, that inspires them. We can't make it up. It has to be based on science and possibility. But we do need to be informed to get some sense of what kind of world will people be working towards in light of these three curves. So that's what we're going to cover, and of course we can't cover it all, but we'll try to skate through it at least a little, and then I would love to hear some discussion. In my world, pediatric neurosurgery, I came into neurosurgery because, as Katie mentioned, I've always been interested in the relationship between brain and behavior. What is it that makes us the way we are? And so to me, the problem of climate change, which was the problem I decided to tackle, influenced in part by that photograph of that child looking out over his future, was to just bring my perspective of the brain to the problem. And to me, to people like me who spend every minute of every day thinking about the brain, it's like everything's about the brain, isn't it? And in one way it is, because everything we do, everything we choose, everything we feel can be explained, not necessarily predicted, but looked at through the lens of how does our brain operate. And how our brain operates is dependent on how our brain evolved as a biologic event through historical time. So the question is, what is it about the way our brains evolved and are designed to work that makes it so hard for us to change behaviors that are destroying our planet? And the second question is, are we flexible enough to change? And to me, that's sort of the key question, isn't it? So what did I do? I did what academic people do, which is I took a sabbatical. Like, it's great. You know, you say, I want a year off, and they say, okay, you go on, not going to get paid, but we'll give you the time off, and you can come back to your job. That's pretty good. So I got this sabbatical at the Harvard Radcliffe Institute for Advanced Study, and it's like summer camp for kids, for adults. You go, and they choose 50 people from around the world. They're from all over, and they're every discipline: filmmakers, judges, politicians, historians, artists, you name it, and a few scientists. I was the first neurosurgeon that did this. And you don't live on an island, but it's close. You all live in like a dorm, and you interact with each other. And I'll tell you, in terms of broadening, I'd been thinking about, how do you do this surgery, and how does the brain respond to trauma? So it was absolutely freeing of my preconceived narrow notions. And plus they give you some students to help you. I mean, it's just great. Like, I highly recommend it. If you can get that gig, it's a good one. And so I'm going to cut to the chase and not tell you how we got to these conclusions. Basically, I and my students read everything we could find about these topics. And basically, when you think about it, why is climate change so hard for our brains? Well, first of all, you can see, most of you who aren't colorblind, you can see colors. You can see the tables are blue, and these colors are kind of orange on the side. You can taste your coffee. You can hear me, most of you. You cannot perceive CO2. CO2 has skyrocketed during our lifetimes, but you can't tell. There was no evolutionary need for human beings to develop the equipment to sense CO2. It was simply not a threat during evolutionary time, and so there was no selective pressure to develop that. So here we have this big, big problem that you can't perceive directly, okay? Another major principle, we'll go over this one because this one's a little more important. Pro-environmental behavior, by and large, is not very rewarding, and we'll talk about what that means. And then pro-environmental decisions, which are what you guys are doing most of the time, they don't feel the same as a decision to buy a new couch or take a vacation. They're like, okay, I feel good about this. This is what I do. Like, I feel good about it. But it is not a zap of reward like your reward system is designed for. So let's get into that in just a little bit more detail. What is reward? We're going to talk about the human reward system. Reward is not what you get when you use a particular credit card and you get points for flying, for example, in the neurobiologic sense. Reward is a system that integrates with the rest of your neural system that is designed to teach you what you need to survive. That's the point of it. It's not designed to make you feel good. It's designed to help you survive. That's the point of most of our adaptations. And we've learned a lot about how this works through, in the old days, it was like weird injuries, like Phineas Gage with the tamping iron through his head. Some of you might have learned about that in biology. To fancy techniques that we now have, single-cell recordings in awake humans and functional MRI and all this other stuff. So we now have it mapped out pretty well. What is it that makes it so great to win a race? What is it that makes it so great to have a steak dinner, for example, or get a bonus at work? What influences our decisions? We think consciously, oh, I decided that because of blank. Like I said, I decided to go down this pathway and take a sabbatical because of that photograph. Well, it wasn't just because of that photograph. It was a million other things. But that was one part of the equation, one thing that tipped the scale. And the way our brains work is that our brain weighs choices second to second based on millions of simultaneous events going on in your brain that neurobiologists call utility calculations. Animals make them too, but we make them. And they depend on your genes, your heredity, your experience, your circumstances. They are rewarded by this biologic system, neurobiologic system, the reward system, largely mediated by dopamine, but not exclusively. It's not like every time you buy from Amazon, it's a dopamine hit. That's a little oversimplified. Sounds good, but not quite. And we have general tendencies, but we are designed to be flexible by nature. We have to be flexible, or we would not have gotten to where we are now. And this did not come from the sky like a computer in a package. This evolved through biology, and it started with single-cell organisms, bacteria. On your left is E. coli, single-cell bacteria. You know it gives you food poisoning sometimes. It closes the beach. But E. coli developed a very smart thing, and it was the basic principle of how everything works in biology, the nervous system, and others, which is some E. coli happen to mutate to have a chemical on the surface of their cell that changed shape when it encountered other chemicals. That's kind of the basic principle. And when it encountered acid, the animals, it would have this like Rube Goldberg kind of effect where the flagella would push the animal away from the acid, and when it encountered another molecule, encountered sugar, it would move the flagella towards the sugar. So here's a single-cell organism, no brain, no nervous system, one cell, making a quote-unquote decision to move towards sugar and away from toxicity. That's how it all works. And that principle of having chemicals that change shape when they encounter other chemicals is basically what built us. When we get to multicellular organisms like C. elegans, some of you who are biologists studied this, maybe you do research in it now. Now we start to have neurons and neurotransmitters that basically let this happen in more and more complex ways. When we get to sea slugs, aplesia, now we have it connected to learning, so that when the animal encounters something, does something that is good for survival, in this case the research was on swallowing sugar, then dopamine and glutamate, which is a transmitter important in learning, solidifies that behavioral connection in the nervous system so that it's more likely to happen next time the animal encounters sugar. So what is the reward system for? It teaches you what you need to survive. Now we get to mammals. So a mouse has about 70 million neurons, and a rat has about 200 million neurons. And in mammals, it was discovered that reward system is tuned to small, unexpected, variable rewards. So if you're a prehistoric hunter-gatherer or a current hunter-gatherer and you're hot and tired and hungry and you're walking through the woods and you encounter this patch of berries, those berries are going to be the best thing you ever had. That's a very, very, so you guys know this if you go camping. Sorry to say guys, it's an old habit. You people, if you go camping and it's the end of a long day and you're hot and sweaty and you get your like dehydrated meal, like nothing ever tasted as good, right? Small, variable, intermittent rewards, especially unexpected. That's how we are tuned to be rewarded. And there are people who believe that modern life messes that up. We can talk about that later. Now, I want to just give you a scale thing here. Rats and mice, 70 million, 200 million. The human brain has 86 billion neurons. And each of them has about 10,000 connections to other neurons. It's an extraordinary mechanism. I had to have an artist make this for the book, this diagram, because there was no current diagram of how the reward system works. But it's really, really an amazing story how it was studied. But I want to step away from that and take you on a time journey to put this in perspective. My students helped me come up with this. I wanted to get a sense of scale, right? Because it's very hard for us to think long term. We're not designed well. So this is an example. This is an illustration that helps you understand where things happened in time. And imagine that you walk across the United States, you start in San Francisco, and the students wanted it to end in the center of Times Square. I would have made the Atlantic Ocean, but they wanted the center of Times Square. It would take you, by Google walk time, if you didn't stop, 40 days. There's something prophetic about that, I don't know, 40 days. And what this represents is the beginning of the Earth, 4.5 billion years ago. Center of Times Square is now. So let's take our walk. Single-cell organisms, like you saw on the last slide, started in Salt Lake City. You get multicellular organisms in, what is that? I can't see it, Iowa City. You get to mammals in Scranton, PA. You get to primates in Morristown, New Jersey. Now we have to blow it up because it's pretty concentrated, so we're going to blow this up. You get to humans when you're 223 yards from the center of Times Square. And here's your last step, the middle of Times Square, okay? Now, below here is carbon. Here's carbon. It's always been under 3,000. Under 300 parts per million until 1950 or so when it skyrockets. Remember, you can't sense it. We did not evolve the means to sense it. Your nervous system, the way it's designed to be rewarded and make decisions, it happened back here. Where is the Anthropocene? Where is climate change? It's when your big toe hits the last step of its 40-day walk. So your brain, it is not designed for this challenge. You can't evolve that fast, plus we've messed up evolution at this time. But your nervous system happened way back then. So when you think about how we make decisions, it's based on what helped us survive, what we needed to learn to survive back here, not now. So what did our brains evolve for? Well, survival. We basically needed more. That's who had the survival edge. Why do squirrels store nuts? Because the squirrel who figured out to store nuts or happened to store, and the more you stored, so more. Early humans, hunter-gatherers, when they figured out how to build shelter, how to store food for the winter, how to domesticate animals, how to create clothing that could help them survive and thrive in harsh climates. More. The more you had, the better you did, the more likely you were to survive. Well, now we have more, and it's counterproductive because it's harming the planet. And I always hesitate. I've shown this picture a lot of times. Is this anybody's house here? Okay. All right. But I always worry, like someday it is going to be somebody's house. And like this, you have very good sensors that tell you that fat, sugar, and salt are rewarding because they were important to your survival. We did not need to develop really good brakes for excess. We just didn't because that wasn't part of what we needed for survival. You usually don't eat till you burst, contrary to Monty Python, but You know, it's easy to overeat. It's easy to overconsume. It's easy because we did not need to develop breaks at a time of scarcity. So as a mental exercise for how your reward system works, just ask yourself as a thing, what's more fun? Thinking about your new car, the make, the model, the color, the interior, or thinking about its energy efficiency? I realize I'm talking to a particular audience here. Maybe some of you, that would be more fun. What's more fun, decorating your house or putting in attic insulation? So I'm not saying what's more like righteous, what's more correct, what's more worthy. I'm saying what's more fun. Fun is your reward system in action. Why do kids have fun playing? Because playing helps them learn what they need to survive. Social interactions, physical skills. That's why play is fun for kids. Whoops. Now, pro-environmental behavior, besides not being terribly rewarding, it suffers from an agency problem. Agency is that cause and effect thing. It's a strong part of how we're built. And, you know, if you're a hunter-gatherer, like you hunt, you gather, you get the food, it's there, you share it with your community, like boom, boom, pretty cause and effecty. Like if I don't do this, I'm gonna be hungry. Building shelter, this happens to be an indigenous shelter in Ireland. Chipping a tool, doing surgery, like cause and effect, like it's great, like I fixed this, right? Biking to work in December in New England, okay, like you may feel like a good person, you may say, okay, this is healthier than riding, but are you gonna look up in the sky and say, look, the carbon dioxide is lower? You can't see that. It's too far away, too big, and so you don't get that sense of immediate satisfaction, except as you process it through your cognition, but it is not built into your visceral reward system, so to speak. Now, to this audience, I want to tell you that in the book there was a whole section, a whole chapter on this concept of biophilia, which you may know that term. It means a hypothesis of that we have an inherent yearning for and connection with nature, as Katie so eloquently pointed it out. And I, being a scientist, said, you know, what's the evidence for this? Is this true? And a lot of the evidence is testimonial. Some of it is, you know, people don't sit at the beach and look at the pavilion, they turn towards the beach. People don't buy houses that, you know, you pay more for nice views, you pay to, you know, so that's sort of practical data, but it's really testimonial level data. But I think the stronger data comes from the flip side, which is what's called ego depression. And, you know, I don't know about you, but every time I see a new clear cut for a development, it breaks my heart. I mean, I get an immediate reaction. You fly over the United States and you look down and there's nothing but human-influenced land. You think to yourself, where's that fox gonna go with her baby? Like, where are they gonna go? People, these population increases, it's just staggering. And then the refuse and the things that we do that destroy the environment. I know this audience, most of you are hurt in your heart by this kind of thing. You know, the tortoise that put its head through some plastic thing and had to grow all deformed like this. I mean, it's heartbreaking. And I think that is as much evidence for biophilia as things that you can't test. The good thing is that these are not your only drives. The drive to consume, agency, these are not your only drives. We also have built in, to a greater or lesser extent, there are people missing them, just like people, you know, not everybody has every trait, and we all have traits on a bell curve. But there are other rewards, like altruism. Humans are very, very influenced by social rewards, thank heavens, or we wouldn't have survived. Problem solving, like this is us doing a surgery where the whole team is there and we're trying to figure out as we go, like that's very satisfying. Altruism, here's a kid, and the mother says he signed his first and last name for the first time. She called the office to tell my secretary to pass that information on. That makes you feel great, right? But here we are facing this crisis that affects everything. As you know, CO2, this is over 800,000 years. This is from the observatory. You know, this rapid, you cannot ignore it. And it affects our health. So physicians like me have gotten more and more involved in this because it is affecting our health worldwide, the theme of your conference today. So I want to just tell you numbers I had to learn. I didn't know this. I did my sabbatical, and I'm like, I don't really know. But I looked this up to try to figure it out. So the US is the biggest contributor to the total CO2 that is currently in excess in the environment. Currently, China is ahead of us in terms of per year, not per capita, because they have a lot more people than we do. And how much do we control in our lives, and how much is controlled by things we can't understand? I read a lot about this, and my estimate is, for averages, you can see it depend on how you draw your circles around the categories, about half comes from things each of us decide, and about half comes from things most of us don't control. So about, you know, there's a lot of us, so for any individual person, your individual choices don't make, like, the CO2 level change when you ride your bike, but there's a lot of us, and it adds up. The US per capita carbon emissions is roughly, now it's a little more like 18 than 20, but for a round number, 20 tons per person per year. We're one of the high emitters per capita. The world average is about 5 tons per person per year. To stay within 1.5 degrees, which is probably water under the bridge at this point, we have to get down to 2.1 tons per person per year. And there's, you know, how do we do that for ourselves? Which behaviors matter most? You folks are sophisticated in this. You probably already know it. I had to learn it. Transportation for most Americans is the #1, how you get around. Plant-based diet is a big deal, which I didn't know before I went down this road. Home energy efficiency for most of us. One less airplane trip. So one trip to the West Coast or back, or to Europe and back, is 2 tons per person on that plane, roughly. And that's your whole year's allotment of carbon. So taking one less unnecessary airplane trip a year will help. If you really want to know, you can put in carbon calculator in Google, and it'll tell you, and you can fill in your own data to see where your carbon footprint is, as you probably know. So the point of this is, are these changes on the top 5 for most individuals in wealthy countries like ours, are they easy? Are they hard? Are they rewarding? It's mostly telling you stuff you can't have or can't do. That's not fun. That doesn't help you survive. Now we have to use our cognitive override to, you know, kind of overcome that system that evolution provided for us to teach us what we know to survive. Luckily, your reward system is both malleable and gullible. And what do I mean by that? Malleable means you can change. Your reward system can be changed in what it finds rewarding, in sometimes dramatic ways. And this is an example of one such dramatic way. This is a functional MRI study of patients with anorexia, where the part of the brain that lights up for most people for food reward lights up for these patients for going without food. That's a 180-degree switch in what's rewarding from what is survival supportive and what is absolutely the opposite. So that's just an extreme example of how malleable your reward system is. This is another extreme example of social reward. And when I say gullible, what I mean is we have an inherent tendency, again, to greater or lesser extent among individuals, to believe what we are told by authority figures. That's how we learn the culture. It was important for us. If you were about to step on a hornet's nest and your grandfather said stop and you didn't stop, there would be fewer of us. So that is an built-in tendency. There are natural rebels, but most of us believe what we're told by authority figures, and not just early in life. In surgery, whatever you were taught as a young adult by your mentors, it's very hard to give it up. Cats are the example I use. It's a little horrifying. I'll do it quickly. In ancient Egypt, as you know, cats were venerated. They were, you know, goddesses and so on. But in Europe, in the Middle Ages, cats were tortured publicly, held by their tails and dipped into fires, and the whole community would go, and kids would shriek with laughter. This was so funny. How could something so awful be funny? Because the religious leaders of the time told people that cats held the devil. And the more the cats were tortured, the more the devil was being tortured. And people believed this because that's how we are. And they thought it was funny and fun. A little hard to believe now, but it's an example of how what is rewarding, what is fun, what is considered good, can be so changeable in our brains. So, now that we know the principles, let's talk about behavior change. What strategies work best for changing behavior, which is what we need to do to affect climate change? And I looked at 2 different things, personal behavior and cultural behavior. And the 2 examples I used were addiction, which is a really hard personal behavior change, and the Ebola epidemic in West Africa in 2014, which required cultural change. And I won't go through all the details. If you're interested, you can look them up in the book if you have any interest. But basically, there are some principles that are in common. 1, Positive works better than negative. Telling people don't do something is not fun, doesn't work very well. It can, punishment can work, but it's not as effective in the long term as positive. Information comes from people you trust, that's the gullibility thing. Why is it surprising that the general public was hesitant to believe talking heads, people they didn't know, that told them about climate change that they couldn't perceive because they don't have carbon dioxide sensors and things didn't feel that different to them? Why do we find that so surprising that people couldn't buy into it for a long time? Now, granted, there was deliberate disinformation. I don't forgive that. Another is you get a substitute reward that's immediate and tangible. That's the basis of most 12-step recovery programs for addiction. And the immediate substitute reward that you generally get is social reward. Social reward is what will carry the climate change and movement of conservation forward. It's being here with other people that are like-minded. That's very powerful for most of us, and that has been our biggest weapon. Making a public commitment, if you say at your town council, we're going to do this, like now you've said it, now you got to do it. Or at the school board, or at the governor's council, whatever it is. And then there are others, but those are the main ones. Now, that's about general behavior. Let's talk about pro-environmental behavior. Change has to be more rewarding than the alternative, or people won't do it. That's just the principle. And the reward may not be you get more money for it, or it may be an internal reward, it may be I feel like a good person reward, it may be social reward, but it has to, on balance, on the equation, when you make that utility calculation, it has to be more rewarding overall. So, what are the principles that have worked for pro-environmental behavior change? Doing differently, not doing without. So, for example, if people walk and ride their bikes and they are encouraged by authorities that they know and trust that this is healthier and you're going to live longer, that's an example of a substitute reward. Financial incentives for business, that's the whole basis of the Inflation Reduction Act. And others, that's in hospitals. The Joint Commission is now suggesting that hospitals have sustainability programs. U.S. Department of Health, the NIH is now requiring in your grants that you say what you're doing for sustainability. And then there's legal things like the Environmental Defense Fund or Conservation Law Foundation that make it financially better to do the pro-environmental thing. Then there's something called honeybee rewards. So this is the Ford 150 Lightning. When Ford came out with its first electric truck, it did not market it as the tree hugger truck. It marketed it at car crushing contests where the torque of this thing could crush the competition quite literally and figuratively. So they weren't trying to market it for its pro-environmental behavior. They were trying to market it to the truck-buying public as more strong and powerful. That's called a honeybee reward, in the idea that the honeybees don't go around on purpose to pollinate, they go around to get the nectar. The honeybee's a side effect. So that's an example of that. And then social rewards from like-minded people, as I mentioned. So, bottom line, what's rewarding can be changed. It's a challenge, but it can be changed. And as we get more and more worried about this curve here, then we need to change what is rewarding. Kids at 4 months can learn to swipe touch screens, and it's really rewarding, and you take it away from them and they are dysphoric, they are unhappy. They did not evolve that. These things weren't around. They had to change their brains and what was considered rewarding. I'm not saying it's good, but in that case. So you want a big Hummer, maybe get a Rivian. You want a fancy sports car, I won't even use the T word today, but you know, I have a Chevy Bolt and I love it, except I'm going to have to figure out where to charge before I drive back. Your clothes have holes in them. Take them to the Fashion Institute of Technology in New York, one of the best fashion places in the world, and they will do what's called radical mending. You can pay them to build into your holes or your rough spots beautiful embroidery. And it's not designed to cover it up or make it look like it was. It's designed to be art. I happen to have a coat with me today, if anybody wants to see, that has been radically mended. You want new furniture? You don't have, I hope I don't offend anybody, but you don't have to get restoration hardware. It's like, ugh, right? But you can go to your local thrift shop and get something that only you can have that is good for the, better for the environment, profile-wise, and shows your cred of, you know, stylistic excellence. So substitute rather than do without. At Audubon in Rhode Island, which I am on the board of, The board felt very strongly we needed to walk the walk and decarbonize. This is Stephen Porter. He happens to be an ecology professor at Brown, and he's also their lead sustainability person for transforming their campus of Brown University to carbon neutral. So Audubon has made a pledge now that we will be net zero by 2030 and true zero by 2040, which means that we will have battery storage to store our solar power and run off the grid 24/7. So this is a public commitment, like-minded people, social reward, and it brings in the reward of biophilia with the sense that this is the problem with, the biggest threat that birds and habitat face is climate change, besides, obviously habitat loss. And so it makes you feel good on an intellectual basis as well. A final note, stuff, it turns out that more doesn't make us happy. When happiness is considered long-term life satisfaction, studies of people followed over decades show that there are only two things that are in common with people who consider their life to have been satisfying and happy. One is a sense of purpose, which you all have, and the other is your relationships, which you probably also have. Even when you're heartbroken, you find new ones. And knowing that stuff doesn't make us happy can sometimes help us overcome that urge for that short-term reward that is not actually helping us survive, even though it might have when our brains were formed in the past. So with these three curves in mind, what is our vision for the future? And not just next week, not just 5 years from now, not our 10-year strategic plan. What has to be our vision for getting over the hump of those three curves and building a world that people can work towards? That is your challenge, and that's your mission that I really respect all of you who are here and work towards this. You can't ignore the threat of climate change, and it, for many of you, needs to be integrated into your lives or your work. It's not fun. Climate change is not as much fun as come outside and have a good time in the wilderness, but it is something that threatens it in a really existential way and threatens people around the globe. So my hope is to hear from you and learn from you about how you're coping with this mission. And my other hope is that I've helped you think a little bit about why this is a challenge and why it will be important for us to think not just in the short or even intermediate term, but in that really longer term view that gives us the future we want. So thanks for your attention, and I think we have a little bit of time for questions, so thanks.
Thank you, Dr. Duhaime. So if you have a question, please raise your hand. We've got a couple people with mics, and we'll run, and you can have your questions answered.
Is this on? Yes. Somebody's got to have a question. You don't even have to have a question. Just tell me your thought. Like, push back and say, that was dumb. Sir.
My question is about the relationship between gullibility and intelligence. And I think it's recently relevant.
Yeah, great. If people didn't hear the question, it's what's the relationship between gullibility and intelligence? No relation. There's no relation. People make their decisions based on the information stream that they get, based on their genetic tendencies. If you're interested in this, in the book there is a section on conservatism versus liberalism as a genetic trait and as an environmental thing that you acquire. And it turns out that there are genetic subtypes of dopaminergic receptors that tend to make you more one or the other. So some of this is actually biologic, but nothing is so simple. And as I said, the way people think has to do with what their grandmother ate for breakfast in the famine 2 generations ago, epigenetic causes. A lot of it is what you are currently consuming for data and information, but a lot of it is where you spent your childhood, whether your brother treated you well or not. all the things that ever happen to you are part of how you make your decisions. They're not conscious. You don't know about them. You can't access them most of the time. But your decisions are made by millions of events, and they change minute to minute. That tendency of gullibility, it's a negative sounding word, and I don't mean it that way, but the tendency to believe what you're told by authority figures also changes minute to minute. There may be a time in your life when you just want someone to tell you what to do, and there may be another time in your life when you're 24 and you think you know everything and you're not so gullible, or you think you're not. Actually, you're influenced by your peers. So gullibility and intelligence have no real relationship. Education, or the ability to consider other points of view, that may have something to do with moderating your gullibility, but it's not intelligence, in my opinion. Yeah? Get a mic, or do I need to go over there?
I can be loud. Say, as a doctor, do you ever prescribe time in nature? Can you share any examples of how you may use nature as one of your healing practices?
Right, great. So for those of you who couldn't hear, the question was, as a physician, do I prescribe nature? I will say that it is something that I tell parents their kids need to do, and I tell them that it will help their recovery. I'm kind of making that up a little, but there's a little evidence for it. And I am an advocate of unstructured, free play by themselves with other kids without supervision, or with distant supervision. And I think that all the evidence that I read from Scandinavia, from other, that's what we don't give our kids anymore, and it is critical to learning. And I also feel that there is some evidence that it helps people appreciate nature. So do I prescribe it? There actually is a program at my hospital where kids can give a prescription for nature, and they can go to certain nature places that will give them free admittance with that prescription. It's called Outdoor RX is the program. Okay? Other questions? Yeah, way in the back here. I'm so glad you're asking questions. I hate when nobody asks a question, so do it just for me.
Hi. Thanks. First of all, this is so interesting, and go Rhode Island. And it would seem to me that based on your presentation and based on current and recent events, that folks who do not want to address climate change are getting a fair amount of social reward from being proud about that and sort of banding with like-minded folks, just like all of us are getting a social reward from being with like-minded folks here today and in the work that we do. And I was curious if neuroscience offers us either hope or techniques for addressing that, and because I think that's going to be fairly important to long-term success here.
Yep, you're absolutely right. So social reward, people use the term tribalism in sociology right now. In my opinion, when the pace of change has accelerated the way it is now, people look for something that gives them security, and social reward and being with like-minded people is really powerful. So how do you counteract it? I can tell you what I know about not what doesn't work. One thing that we know does not work is giving people more information alone. Information in and of itself is very ineffective. But partnering with other kinds of rewards can either change people's mind, or you embed them and hide them in honeybee rewards, okay? So the medical community, I'm on the steering committee of something called the Medical Society Consortium for Climate and Health, which is an organization that brings together multiple professional organizations of different specialties. So it has about 700,000 physicians in the US represented. And the push there by people that we work with that are climate communicators is the honeybee reward that may work with the general public is health rewards. So it turns out that, as you all know, carbon dioxide is global. So when you release carbon dioxide, it goes everywhere. It doesn't matter where you released it. Pollution from fossil fuel combustion is local, and the health effects are local. So if you switch to electric buses in an urban area, there is good evidence that those kids that take those buses and those people in the community have immediate benefits from that. Apart from the CO2 benefits, it's the pollution benefits. If you protest a peaker power plant in an already environmentally, denigrated neighborhood, a social justice, or I like to say social injustice neighborhood, those people will benefit health-wise. If people take public transportation or bike, there's health benefits. If they switch to a less red meat-based diet, there are health benefits. So those are the honeybee rewards there. So pollution is local, and you get health effects from that. I think it's interesting that this administration, incoming administration, said we'll have the cleanest air and the cleanest water. I get it. But people do want clean air and clean water, and fossil fuels are an anathema to both. So not confronting people with information that they are challenged to absorb. Remember, there's a ton of disinformation out there by vested interests that are economically motivated, but you can maybe appeal to them that way. And the other superpower a group like this has is the attraction to nature. I mean, that's a big honeybee reward, right? And pro-environmental, you sneak it in, the information people can absorb if they're in the right mindset and mind frame. It'd be nice if we could, this is an aside, if we could plant enough trees to overcome climate change. We cannot. The equation is wrong. We have to stop fossil fuels. So land protection is really important. Unfortunately, it's going to compete with renewable energy to some extent. There are realities. We can't have everything. We are going to have to sacrifice in some ways, and the question is, where's the best sacrifice? So I don't know if that answers your question, but maybe it gives you a little bit of answer. There was another hand someplace.
This might be a related question, but thinking in terms of human behavior and in the world that we live in, how do you think about the the powerful influence of advertising and social rewards in this very profit-driven economy that we're in that keep pushing towards more and more and more and more?
Yeah, Katie, how are we doing for time? We're good? I'm so glad you asked that question. I would have planted it had I thought about it. So I have thought for at least 30 or 40 years that the phrase that popped into my head then and has only gotten stronger is we are an over-entertained society. And when you think about that from reward, somebody is trying to sell you something. And whether it's sports betting, the pot drive-through, Netflix, I mean, you name it. In my lifetime, the amount of entertainment people have available to them, and I'm using the term kind of global, kind of broadly, I mean, it's like the science and technology curve. I mean, it's like exponential. If you have a pretty tough life, you know, you're getting along, but you know, you're working 2 jobs or scrambling to stay ahead, and you come home at night and you gotta like deal with your household and your kids or whatever, and you have an hour or 2 to yourself. Think about it from a reward point of view. What's more fun? Ask what's more fun. Is it more fun to read news and policy and understand where inflation came from, that it was pandemic spending and so forth, and it's not really the Biden administration's fault? Is it fun to like delve into this stuff you don't know much about and you don't really understand, but you're going to try because you're a good citizen? Or somebody trying to sell you something and entertaining you for the next 2 hours? Which is more likely to be chosen? Like, this is not evilness, except that I think our capitalist society is, you know, really unbalanced in terms of who makes what off of whom. I mean, I think that's really a problem for us as a society. So I think the answer to your question, from my mind, is it is homework to be informed. It is not much fun, and it is homework. One of the things we're doing at Audubon with our Repower campaign is every single thing we do, every time we're putting a heat pump and getting rid of an oil burner in our refuge buildings, we're going to put a plexiglass wall over that ductwork with education and show people how it's done. Because we're embedding the knowledge that is homework into something that is, quote unquote, more entertaining or fun. Finally, I'll end with the fact, I see we're getting out of time here, but one of the things I'm working on is I got funded to do a scholarly working group at Harvard on the intersection of climate change, war, and health, which I think is a real issue. To me, we have this slow asteroid of climate change coming at us, and we are wasting incredible human capital, suffering, resources, monetary, on war. It's like so short-sighted. Both climate change and war are preventable problems, but writing papers with this scholarly group and putting them on a shelf isn't going to get us anywhere. So our plan is to make a movie. And the movie we are modeling it after is the 1983 movie The Day After that was about nuclear war, and it was on network TV. And after the movie, they had a panel with Henry Kissinger and Carl Sagan and a few other people, and it actually changed public opinion, and more importantly, Ronald Reagan, and helped move his needle towards nuclear treaties. So we're using that model to try to sneak education and a realization of more long-term thinking into the general public. Whether we succeed in that, I don't know. I'm not trying to compete for funding. I mean, we're going to have to work hard to make this into a reality. But I think you have to speak to people in the language. The reason that movie was successful, for those of you who don't know, it was a fictionalized version with real characters, real actors who played parts of people you could know. And that's, I think, why it succeeded. So wish us luck, but that's my goal.
Thank you again, Dr. Duhaime, for such an insightful presentation. You highlighted a reminder of how we can rely on one another and our strong partnerships for positive change.